let's look at a few more examples of trig identities just from the book. And I'm going to have some, I might have some guest voices on this video. But let's look at number 35. Tan theta plus cotangent theta equals secant theta cosecant theta. So this is an identity to prove. And one important thing is, remember, you can't take this equation and manipulate both sides. You need to start with one side or the other, manipulate it, and if you get stuck, you can start from the other side and work towards the middle. But don't treat it as a known equation that we then manipulate. That's backwards logic. Here we've got tan, cotangent, secant, and cosecant. We've got 4 different trig functions, so it's not the only way to do it, but probably a good strategy is just to put everything in terms of sine and cosine. And so we're going to look on the left-hand side. Okay. And so the left-hand side, so actually tell you what we'll do. We'll just rewrite that, okay? So I'm going to put a little question, I'm going to put question marks here. We don't know that yet. But we do know that the left-hand side can be expressed in terms of sine and cosine. Now there's a common denominator there. And as soon as we do the common denominator, we should recognize something very significant. So sine times sine, sine squared, cosine times cosine is cosine squared, over cosine theta, sine theta. And that's 1 on the top. That's the Pythagorean identity. And that is just 1 over cosine times 1 over sine. Oh, that is just exactly secant theta times cosecant theta. Okay. And we're done. We don't even have to write any more. We've got a chain of equalities that go from the left-hand side of the proposed identity to the right-hand side. And so that's a good way to show that. We didn't manipulate it as a unit, but we've shown that it's true. Okay. 41 here. This one's another pretty easy one, but one of the things that people are reluctant to do very often is when you have a difference in a numerator, this isn't just in trig identities, it's basic to algebra. When you have a difference in a numerator, one thing you can do with that is you can just split it up. Another strategy here, I could have sort of started with either of these sides here, but I guess the reason I started with this side up here is that I knew it was going to be the more complicated side. Usually you want to try and start with the more complicated side and then reduce it. The reason I knew it was going to be more complicated is I knew as soon as it was sine over cosine, it would have it would be a sum of fractions. And the reason you start with the more complicated side is that that gives you some meat to work with. You can simplify instead of introducing complexity, which is harder. So I'm going to work with this, which certainly looks like the more complicated side. And if you're not sure which is more complicated, don't worry about it. Just start with one side or another. Okay, so I'm going to start with the left-hand side, and I'm going to realize that I can split up a numerator. And so that's just going to be secant over secant, which is 1, minus cosine over secant. Okay. Now, cosine and secant don't particularly play well together, so I don't want to leave them in that form. I want to change secant to 1 over cosine. Okay, and then how do I... Ooh, that's not a power. That's not a power. How do I divide by a fraction? I multiply by the reciprocal. So that's cosine t over 1 for the top times, and I'm going to flip the 1 over cosine, so that's going to be another cosine t. This is where you have to be really careful. It's very easy to flip twice, or flip not at all, or just get the flipping wrong, basically. I'm dividing by 1 over, so I'm multiplying by just plain cosine over 1. Do it slowly, take a deep breath, be careful. And so that's just a fancy way to say 1 minus cosine squared t, and that we need to recognize with the Pythagorean identity as sine squared t. And we're done. Oh, that's how you spell done. Okay, so now we're going to pause. Actually, that's good for the first part of the video, and I'll split it up into 2, and we'll do the next